Welcome to G Fun Facts Online. Have you ever considered where the flavor in your yogurt, beer, or sourdough bread comes from? For centuries, we've relied on a small, domesticated caste of microscopic organisms, yeasts and bacteria, to ferment our food. But what if I told you there's a vast, untapped wilderness of these flavor makers, a hidden workforce that could completely revolutionize what we eat? And what if I told you this workforce lives inside insects? In the quest for a sustainable food future, scientists are looking past the insects themselves and into their guts, discovering a microbial world that promises to create a new generation of foods. This isn't just about finding new flavors. It's about unlocking solutions to some of the biggest challenges facing our global food system. Insects are the most diverse animals on Earth, and they host an equally staggering diversity of microorganisms. These microbes aren't just passengers. They are vital partners that help insects digest everything from tough wood fibers to plant toxins. In doing so, they've evolved unique metabolic pathways, producing a huge catalog of enzymes and compounds that are now catching the eye of food scientists and even avant-garde chefs. We're on the edge of a new fermentation frontier. The journey has already begun, with discoveries ranging from tangy yogurts made with the help of ants to savory sauces packed with umami derived from mealworms. So today, let's explore the science of this unseen workforce and how it's shaping the future of food. To understand the potential, we first have to appreciate the ancient and intricate relationship between insects and microbes. The gut of an insect is a vibrant microbial city. These tiny organisms produce enzymes that can digest things their hosts can't, like cellulose and lignin. The gut symbionts of termites, for example, are legendary for their ability to break down wood. Microbes in other insects can neutralize toxic plant compounds, effectively disarming their food source. They also synthesize essential nutrients like vitamins and amino acids that might be missing from the insect's diet. This constant evolutionary pressure has turned insect microbiomes into a treasure chest of unique and potent biomolecules. It's this specialized toolkit that makes insect microbes so valuable. Scientists are now bioprospecting these communities, searching for novel strains of bacteria and yeast that can be isolated and put to work, moving beyond just eating insects to harnessing their microscopic partners as a new generation of starter cultures for fermentation. While this sounds like cutting-edge science, the idea of using insects in fermentation has surprising historical roots. In parts of Turkey and Bulgaria, a traditional method for making yogurt involved adding live redwood ants to warm milk and burying the container in an ant mound to ferment. It sounds bizarre, but recent scientific investigation revealed a sophisticated process. The ants carry lactic acid bacteria and acetic acid bacteria on their bodies, including a species also found in sourdough starters. These bacteria are the main drivers of the fermentation. But the ants also play a direct role. They release formic acid, a natural defense chemical, which lowers the milk's pH and creates the perfect environment for these acid-loving microbes to thrive. The ants and their bacteria also contribute enzymes that break down milk proteins, resulting in a uniquely tangy and herbaceous yogurt. This tradition is a powerful proof of concept. Inspired by this, modern researchers are now isolating specific microbial strains. One of the most famous examples comes from Dr. Anne Madden, who discovered a new species of yeast in the belly of a wasp that turned out to be exceptional for brewing sour beer. This yeast could produce that desirable sour flavor faster and more effectively than many commercial strains. Think about that for a second. A yeast from a wasp, outperforming centuries-old brewing strains. Other experiments have used yeasts found in hornets to create unique sourdough breads. This highlights a massive paradigm shift. Instead of relying on the same handful of domesticated microbes, we can now tap into a vast, wild library of yeasts and bacteria with entirely new characteristics, offering a whole new palette of flavors and aromas for everything from beer and wine to bread and cheese. The true frontier, however, is using these isolated microbes as controlled starter cultures. This gives us greater control, safety, and scalability. Take the dairy industry and its plant-based alternatives. One of the biggest challenges for vegan cheeses and yogurts is replicating the complex flavors of their dairy counterparts. The lactic acid bacteria used in dairy are often not optimized for plant-based substrates like soy or oat milk. This is where insect microbes could be game changers. Scientists are isolating novel lactic acid bacteria from insects that are naturally adapted to breaking down tough plant materials. These microbes could ferment plant-based milks to create more complex and appealing flavors, improve texture, and even enhance the nutritional profile. Early research is already exploring plant-based camembert-style cheeses using specific mold and bacteria cultures. Introducing robust new strains from the insect world could accelerate these innovations, leading to vegan cheeses that are desirable products in their own right, not just substitutes. Then there's the quest for umami, that deep, savory flavor we crave. Fermentation is a well-known way to create it by breaking down proteins into amino acids, like glutamic acid. Here again, insect microbes show immense potential. Researchers have created fermented seasoning sauces using mealworm larvae, adapting traditional soy sauce techniques. They found that these insect-fermented sauces had significantly higher levels of free amino acids, responsible for umami and other desirable flavors. The protein breakdown was even more efficient than in traditional soy sauce. This opens up a whole new category of condiments, and the market for such innovative products is already emerging. The edible insect market is projected to reach billions of dollars in the coming years, and these kinds of processed, ingredient-based products will be a major driver. Even classic vegetable fermentation, like making kimchi or sauerkraut, could be transformed. Instead of relying on the microbes naturally present on the vegetables, which can be inconsistent, we could use defined starter cultures derived from insects. Since many insects feed on plants, their gut microbes are already adapted to these substrates. Using them could lead to products with novel flavor profiles, better safety, and a longer shelf life. But the benefits go beyond flavor. The metabolic action of these microbes can unlock a wealth of health-promoting compounds. When microbes ferment protein-rich substrates like insect flour, they break down large proteins into smaller fragments called bioactive peptides. These can have antioxidant, antimicrobial, and anti-inflammatory effects in the human body. For instance, peptides from mealworms have shown promising antioxidant capabilities. Fermentation makes these compounds more bioavailable. Studies show that fermenting insect flours can significantly boost the antioxidant capacity of the final product. This could lead to new functional foods designed to combat oxidative stress. And of course, there are the probiotics. Fermented foods are a primary source of these beneficial live microorganisms that support our gut health and immune system. A diet rich in fermented foods has been shown to increase gut microbial diversity and decrease signs of inflammation. While specific research on the probiotic effects of foods fermented with insect-derived microbes is still early, the potential is enormous. A study on mice found that a diet supplemented with fermented mealworms significantly increased their population of beneficial lactic acid bacteria. Introducing these novel probiotics could offer new ways to support our health. Of course, this fermentation frontier isn't without its challenges. The first and most important is food safety. Whenever you introduce new microbes into the food chain, you need rigorous safety assessments. Researchers are developing controlled fermentation processes with well-characterized starter cultures to mitigate any risks, ensuring the final product is free from contaminants and harmful bacteria. Then there's the regulatory maze. In many places, insects and their derived ingredients are considered novel foods and require a lengthy, expensive approval process. The rules for isolated microbes can be even more ambiguous. Harmonizing these regulations across different countries is critical for fostering innovation. And finally, perhaps the biggest hurdle is the yuck factor. In many Western cultures, insects are simply not seen as food. This cultural aversion is a major barrier. But research suggests it's not insurmountable. Consumer acceptance is much higher when insects are processed into an unrecognizable form, like a powder. The same principle applies here. If the final product is a delicious yogurt or a savory sauce, and the microbial origin is framed as a story of innovation and sustainability, consumers may be more willing to try it. Marketing that focuses on unique flavors and nutritional benefits, rather than the insect source, will be key. The exploration of insect microbes for food represents a true paradigm shift. We are returning to nature's wild pantry to find a hidden workforce of microorganisms. This isn't just about making ant yogurt or wasp beer. It's about fundamentally expanding our toolkit for creating a more diverse, flavorful, and sustainable food system. We can develop new starter cultures for complex flavors, unlock bioactive compounds for healthier foods, and do it all with a lighter environmental footprint. The path forward requires rigorous science, clear regulations, and clever communication. But as researchers continue to isolate and deploy these remarkable microbes, they are writing the first chapter of a new culinary era, one where the smallest of creatures and their even smaller partners help us solve some of our biggest challenges.